Science at the University of Wisconsin-La Crosse. He received bachelor's and master's degrees from George Mason University and his doctorate degree in exercise physiology from the University of Kansas. His life is dedicated to his family, his students, and to the pursuit of never-ending improvement in all aspects of human performance.
Thank you. All right, thanks everybody for coming. Hopefully you'll get something out of this. But my main research area is in monitoring athletes, and we just do athletes at UWL. I did work with some athletes at University of Kansas, but I've only been a professor for 3 years, and so between some of my grad research started, my monitoring research started towards the end of grad school for me, so it's only been about 5 years that I've spent monitoring athletes. And I'm not going to talk about all the sports or athletes because there's not enough time, but we'll mention some of those, especially some individual sport athletes. By individual sports, I mean weightlifting, powerlifting, swimming, track and field, different, as opposed to team sports like basketball, football, baseball, etc. And I will say too, there are some, I'm going to talk to you about the different tools that I have liked to use, that I'm experimenting with and trying to learn more about. But there are people at UWL that are using different tools that may be better or more interesting. I'm not really sure. I know Glenn Wright is doing monitoring research that involves GPS and other different types of accelerometry and things like that. But I use some different tools. And the main research question that we've been trying to answer is, are the athletes responding to the training program as predicted? This would have been a good opportunity to provide a nice picture of this, but if you think of kind of the standard textbook picture you would see of traditional periodization, and how with an individual sport athlete, as opposed to saying we have to be awesome for every single football game we have to win, it's more so I have to be awesome for the national championships, or if you're an international class, the world championships or the Olympics, etc. And so at the beginning of the season, you could be hitting marks that aren't that great, but towards the qualifying period and towards the really big meets, the most important time of the year, that's where you've got to peak. You have to get your absolute best. So in the process of periodization, for anyone who's unfamiliar, the idea typically is, okay, if right now you don't have to be that great, I can train you harder to hopefully get a better adaptation later. It is going to cause some initial fatigue to the point where right now you're going to be a little bit slower and not quite as skilled, but after we taper and we reduce the training stress, you're actually going to be faster than you were before we started. You're going to be stronger, faster, more athletic, and have more potential to perform better. So my main question, the way I look at this is, when the coach says the athletes should be tired, they should be working really hard this week and not performing their best, is that the case? And then when the coach says the athletes should be fresh, they should be well rested and performing better, is that actually the case? So that's kind of the question I've been attempting to answer. I'm not sure that I have been able to answer it, but we've been able to make a little bit of progress towards it. So there's many different monitoring variables you can use. One of my favorites is salivary hormones, mainly just because I think it's cool. But we look at testosterone and cortisol and then the ratio of testosterone and cortisol. There's not enough time to really get into why, but there's definitely a plethora of data supporting the idea these hormones are really related to performance in a lot of different sports, especially anaerobic sports, but also aerobic sports. And so they're related in two different ways. Number one, athletes who tend to have higher testosterone typically perform better, which is why doping is an issue. And then there's also, when it comes to chronic training stress, your testosterone, your cortisol, and the ratio of those two hormones, when someone is training really, really hard, this ratio is typically suppressed, it's usually lower, and performance is usually down with it. And then if someone goes through a taper, usually this ratio comes back up, sometimes even super compensates and goes to a point where it's at a higher level than it was when the person started. And performance usually rises and falls with that marker. So this is kind of an objective marker that we use. And I'll talk a little bit more about that. We're going to talk about a couple different scales, the perceived recovery status, the perceived stress scale, and then a daily recall. We'll talk about why that's important. And then we do some really simple stuff like vertical jump, broad jump, stand throw, and then we look at things like body weight and anthropometric stuff. With the hormones, I use saliva mainly because it saves a lot of time and it reduces a lot of the other issues. So traditionally, up until probably about 10 years ago, I mean, people were using Saliva more than 10 years ago, but Saliva probably became bigger around 10 or 15 years ago. But before that, people were traditionally using blood. There's nothing wrong with that, but you really need to do it in a very safe, controlled lab setting, and it takes a lot of time. So if we have 20 athletes and we want to collect blood from all 20, that's going to be a really time-consuming thing. We can't do it at practice. It's like, okay, you get your blood drawn, then you go start your warm-up and the next person. Saliva, if I wanted to get everyone's saliva right now, and I had some of my students with me here, and I usually have, we're very blessed at UWL, we have a lot of students who want to be involved in this stuff. My students would come in and they would hand everybody a swab. Everybody hold the swab in their mouth for 2 minutes while they answer our surveys. Then we'd collect the swabs and it would be done. So in 5 minutes, this whole room would be starting to warm up together as a team. So even though you think of track and field, it's like, well, that's an individual sport, but they're in a team setting, training together as a team at college. And so if we have 20 swimmers or 20 sprinters or whoever, we can get all of them at pretty much the same time. So the very first thing someone does when they walk in, we have them rinse their mouth out with water and sit down. We put a swab in their mouth and start the timer. Once the swab's in their mouth, then we have them start answering the surveys. The swabs then get put in these special centrifuge tubes. They go in a freezer. They're frozen at -80 Celsius. And then we use these kits. I'm in no way affiliated with any company, so I'm not trying to advertise for anybody. This just happens to be the kits that we always use. And I've done several hundred assays with this company. We get pretty consistent results. And there's one of our students right there actually performing an assay. So we do the assays later when we have everyone's samples so you can get better accuracy. So while the samples are in their mouth, one of the first things we have them do is the perceived recovery status scale. And this is literally just how recovered do you feel on a scale from 0 to 10. Now one thing, this scale, to my knowledge, came out from Laurent et al. In 2011, and those researchers suggested that this scale will be used before or after a warm-up. And so unfortunately for some of our studies, not all of them, we did this before warm-up, but I'll kind of skip ahead. In one of our studies we said, well, is there really a difference between if you do this before the athletes warm up or after? So we kept it like we normally do during the saliva collection before they do their warm-up, because saliva is always done first while they're at rest. And then after they did their warm-up, we asked them again, and the numbers actually did change. And not only were they different, but they were more strongly correlated to all of our performance markers and other markers after the warm-up. And so the basic idea there is we all walk in this morning and we write down on a scale how recovered do we feel. That number might be more on the lower end. But then we might do 15 minutes of exercise and all of a sudden say, hey, you know what, I actually feel pretty good. This probably happens less often, but I don't know how many of you have ever shown up for training before and you're feeling pretty good walking in, and then you start warming up or doing other things and you're like, wow, I actually do not feel that great. Something hurts, or I'm actually starting to feel pretty tired and sluggish. So it does seem to change after warm-up, but most of our studies we did this before the warm-up, so that's something that we're changing going forward. Perceived stress scale. Please raise your hand if you can read any of these questions. You guys read that stuff? Okay, so it is. I have awful vision. I probably couldn't read it from the experience, but this is just basic lifestyle stuff. And we ask them, when we do our monitoring studies, we usually collect data once per week at the same day at the same time. So before their Thursday afternoon practice, everyone shows up at 2 o'clock exactly, and they put the swab in their mouth and answer these surveys. We ask them, it says the last month, but we ask them to think about the last week. So it's okay, in the last week, how stressed out have you felt, how on top of things have you felt, things like that. The reason we throw this in there is to try and understand, is there something affecting their performance and hormones that is not necessarily controlled for in their workload or in their diet or something else. And so you do have, I mean, the student athletes have very stressful lives. They got a lot of stuff going on. And just like everybody else, they have families and romantic relationships and things. So there's all different types of major stressors. This is a really important tool, in my opinion, for the athletes who are close with their coach, and the coach and the athletes are willing to consent to say, yes, my coach can see this data. You know, sometimes we indicate that, like, hey, your athlete who's normally at a 10, they're at like a 30 this week. You might want to talk to them and see what's going on, because, so for example, let's say you have an athlete who's training really hard, they're doing well, and it turns out they have 3 exams coming up in one day. they might actually be better off skipping practice and studying, just because of the effect it's going to have on their recovery and everything else. And other things too. So when the athletes consent to give the coaches their data, we're able to share this with the coaches, and some of them, they won't share with me what happened specifically in details, but listen, this really did help. So when we collect this data, we usually send a report to the coach right afterwards. So we do the data collection, we get everything organized into a spreadsheet and send it to the coach and say, hey, this is how things are looking this week. Daily recall, man, I don't have enough time to tell you everything I want to tell you about this, but basically a lot of different factors can negatively affect the hormonal component. So is your testosterone up or down? Is your cortisol up or down? Simple things as how long ago did they get out of bed? That's a big thing. I remember one time in a study, there was an athlete who all of a sudden 1 week they had this enormous increase in cortisol. I was like, I wonder what happened. So I was trying to talk to the person. I was like, did you get in a car wreck or something like that, like right before? Cause it's really weird when you see a huge spike in resting cortisol. So you're not at exercise, you're resting right here in the chair. That usually means that something super stressful has happened in your life. It could also mean one more thing, and it could mean that you just woke up. So in these studies, we do them in the afternoon, and we say you've got to be awake at least this many hours beforehand. But there was a guy who had accidentally slept in until the time of data collection, and he was afraid to tell us. He was like, I don't want you to be mad at me, He was a great guy, but I was like, no, you gotta tell me so we know for this stuff. But so when someone first wakes up, if you're healthy, you should have really high cortisol when you first wake up. And after about an hour or two, it comes back down to normal. So I was like, well, the good news is you have normal waking cortisol, it appears. I'm not a medical doctor, so I can't say that for sure, but it's a good sign that normally when you're awake, it's pretty low, but it gets up high when you first wake up. So anyways, we look at that type of stuff, and we do try to quantify the estimated amount of quality sleep, but normally we're just using this to identify outliers that we can't otherwise identify. So for example, if this sheet looks almost identical to every other week, but suddenly there's some other variable that's changed dramatically, we start to say, okay, there might be something going on here. But if the only thing, if on here it says that they suddenly got 3 hours of sleep instead of their usual 9, that's usually, okay, that's probably what's going on. Or they woke up later than usual, something like that. So this is really just to check for consistency. Is there something else explaining the changes in the variables that we're having? So physical testing, we started doing a lot of vertical jump testing on a contact mat, and then estimating jump peak power using the Bahman-Johnson equation, which is an equation derived from collegiate athletes that looks at your body weight and your body height. So it adds another dimension. And it actually was developed with collegiate athletes, a more recent equation. I'm not dissing on any of the older equations, they're great too, but that's just what we started using. And when we do this, we try to keep it as simple as possible. So we try to go hands on hips, short counter movement. We just say short counter movement as quick as you can. We try to get them very consistent. And what we wanted to do is see, it's like, what's the simplest non-technical power assessment that we have the technology to do. We just do that on a contact mat. I do think doing it on a force plate or something else would be better. And so in a situation where you can do that, that would be nice. We also look at broad jump, and broad jump's pretty interesting. I really like the broad jump, but it's also very technical. With most people, if they had broad jump, if they had subpar broad jump technique, you could probably add a foot to the broad jump in about 5 to 10 minutes of instruction. You can make a pretty big difference if someone is pretty athletic but they're struggling with it. So we have basically a less technical power assessment and a more technical one. What's interesting was we did some research with the throwers at UWL, and they're pretty well trained in the broad jump. Their coaches spent a lot of time using the broad jump as a tool, so they actually had the skill down pretty well. The broad jump actually seems to be more related to their other recovery variables than the simple vertical jump test. Whereas in other athletes that were less experienced with the broad jump, the vertical jump test seemed to be a little bit more related to their other recovery variables, which I thought was interesting. And I think part of it too is just because of the the aggressiveness component. So if you think of correct technique during a broad jump, the counter movement where your body goes into flexion, followed by a maximal extension of the whole body, but going at kind of an awkward takeoff angle, and then suddenly right before you land getting into maximal flexion again, or as much flexion as you can handle. It's really a very aggressive test compared to just a hands-on hip vertical jump. With the throwers, we also do a stand throw. At UWL, all the shot putters do the spin technique, which I've heard some throws coaches refer to that as more risk, more reward, or greater risk, greater reward. It's something where you can actually be really, really well physically prepared, but just have a little bit of a bad day with your timing and have a really bad performance compared to your best. But the stand throw is literally just standing in place, dropping, and launching as far as you can. So it's a much simpler technique, and it's pretty well correlated to throwing performance in the literature. So in the studies with the throwers, we also look at their stand throw. And then with swimmers, we've looked at a 50-yard swim test. We've done other studies too. I mentioned Glenn Wright earlier. He comes up with some pretty neat sport-specific tests for different sports. He's got a sandbag test for wrestling and things like that. So there are other tools that I won't get into today, but if he's able to make it next year, maybe we could talk about some of that stuff. So due to the length of the presentation, I can't actually go through all the data we have, but there's some main points that I want to make here. One of the main points that I want to look at with these different studies is some of the issues with how we analyze data as a professor versus as a sports scientist. So as a professor who's trying to earn tenure, promotion, retention, that type of stuff, I need to get my data published in good journals. That's really hard to do with sports science monitoring data. In fact, you usually get rejected by the editor of the journal before it actually goes out to reviewers. But part of the issue is the way you do statistics. So when I give this weekly report with individual data to the coach, it is very valuable to the coach, if the coach uses it. Coaches don't always want to, they're extremely busy, and they have other jobs besides their coaching. So the coaches don't always want to use it. But in the cases where the coaches do use the data, they find the individual data very useful. The group data, though, is usually kind of all over the place for a lot of reasons. So for the group data, one thing we end up having to do is excluding a lot of subjects because of either missing data or because technically they had data, but there was something else, like they woke up immediately before testing one time in the middle of the study, and so we lose data. We have data we have to throw out, and so from a publishing standpoint, it's very hard to get enough subjects and enough data, and to use traditional statistics like repeated measures ANOVA. Is the group changing together over time? Paired t-tests and Pearson correlations and things like that. So this study with powerlifters was done by a grad student, Matt Mosman. I do all the studies with the students, but really it's a partnership. And so in this study, he did find some significant group changes over time. And so what I mean by this is not that everyone has the same amount of testosterone or everybody has the same exact perceived recovery score, but basically in week 1, from week 1 to week 2, all of us had an increase in testosterone and an increase in our perceived recovery. Then from week 2 to week 3, all of us had a relative decrease in both of them. So basically as a group we were changing. So it's kind of weird when you get no statistical significance and a low effect size. It doesn't mean that nothing's happening. It doesn't mean that testosterone didn't change. It just means that for half of us, testosterone went up and for the other half it went down or something like that. So basically we're changing differently. So what's interesting is with the powerlifters who are on the exact same program that is using percent of 1RM and all of the reps were predetermined ahead of time, there was zero auto-regulation in the program. This was written by a powerlifting coach who then coached them through the program. They actually changed as a group for quite a few of the variables. And I found that to be somewhat surprising, except when you look at the type of, we had really good powerlifters, really good, highly competitive, some of them internationally competitive. And I think that they were so dedicated with everything outside of the gym. Their sleep was exactly the same. Their eating was exactly the same. Their lifestyle was exactly the same. So they were super dedicated to what they were doing. So in response to the training program, they changed exactly the way you would expect them to. Another interesting study from a grad student, Kyle Peterson, KP, here in the audience presenting later today. We looked at broad jump and testosterone and cortisol and TC ratio in weightlifters, and found that over time, they did change as a group. Now, this is actually looking at daily changes in 1 week. So we looked at Monday, Tuesday, Wednesday, Thursday. How are their hormones changing and how is their broad jump ability changing? And we found that they changed as a group when it came to testosterone, their TC ratio, and their first broad jump. The most interesting finding in this study to me, and I don't know, KP might feel differently, I'm not sure, but to me the most interesting finding was that what we expected to happen, happened. So KP was the head coach at the time, and I was also his assistant coach, and basically he would have a hard day, a really stressful day, and then a light day, and then another hard day, and then a light day. And on the day after the hard day, when they came in for their recovery day, their active recovery training, their hormones were suppressed. So it basically looked like their body was under greater stress. So then they have a lighter recovery day. They're still training, but very light loads and low volume. They come back the next day, and they're fully recovered from a hormonal standpoint. I thought that was pretty interesting, because even though that's what you would expect to happen, we don't know that that's happening. I'm not sure that too many people have looked at daily changes before, so it'll be in print one day. If you guys have ever heard the name Will Hopkins, Will Hopkins is a researcher who looks at changes in magnitude and effect size. There's a different way of looking at sports science research and statistics. So I'm unqualified to tell you much about it, but if you go to Will Hopkins' website, you'll see a lot of free explanations on how he does it. I think it's worthwhile, but KP had looked into this stuff and actually did a new analysis looking at this magnitude of effect, which I thought was pretty cool. It's basically looking at effect sizes and confidence intervals and things like that. So we've been doing a year, we kind of started to hopefully do a yearly tradition with the throwers at UWL, and we've done 2 studies so far, and the third one will hopefully be this year. And it's the indoor season, from the start of the indoor season to the end of the indoor season. And we're looking at changes in these different variables. And in the study we did last year, they all changed as a group in response to the training program. However, in the study that we did this year, 2017, the only variable they changed as a group was in the stand throw. So we found that really interesting. 1 year, everyone changes almost exactly as a group. The whole team goes up or goes down. And the next year, they were all changing in different directions each week. So that's something where, as we tell it to the coach, we try to figure out why, and it's hard to tell. But the coach then gets to look at, okay, what changes did I make this year? And does that matter? Does it matter if they were changing as a group or not? Because he did have quite a few All-Americans this past year. They had a really good year, especially indoor. They had, I think, 3 All-Americans in the weight throw. So they had a very good year, but they weren't changing as a group. But the individual data was pretty neat and pretty interesting. With cross-country, men and women, we didn't see too many group changes. Just for the sake of time, I'm just going to rifle through this now. But for the women swimmers, we did actually see some group changes in hormones, which I thought was pretty interesting. And so I want to leave you with 2 final thoughts. One thought is, with the swimmers and the throwers, the coaches were they had a plan going into it, but they also used some level of auto-regulation, where basically they'd say, okay, we're going to be doing about this many reps, about this many whatever, but if the athlete looks like they're not having a very good day, we're actually just going to cut it. At some point we're just going to say that's enough. And I think that's why, especially in the swimmers, because the coach was really big on doing that with his swimmers, I think that's why they changed so much as a group, because even though people are going to respond differently to the same workout, he was willing to say, okay, this person's had enough. This person you're going to keep going, but this person you've had enough. And apparently had a pretty good eyeball for it, because they ended up responding to the program the way you would have expected them to. And I thought that was pretty interesting. But when it comes to actually helping the coach, I found that the individual correlations were much more important. I'm not sure that I'd ever get data like that published in a peer-reviewed journal, but for actually helping the coaches and the athletes, just looking at, here's your 15 time points, and with PRS and testosterone, you've got a 0.86 correlation. So almost every time that you say you feel better, your testosterone's higher, which is a pretty good sign that, you know, this athlete is pretty in sync with their recovery variables. Same thing with vertical jump, broad jump, jump power, things like that. We also found interesting things like a lot of athletes, their sleep and their body weight, when they had more sleep and heavier body weight, they actually had very strong correlations with higher performance and higher testosterone and lower cortisol, things like that. So it was interesting to see how when we look at the group data, we don't see a lot of really strong relationships between these things, but if you look at individuals, with a lot of them you see pretty strong relationships between the different monitoring variables and then the other performance variables. So. All right. I don't know if I saved time for questions or not.
This is like one.
Okay. Yes.
I'm also in exercise and sports science department. I'm curious, you got, some pretty large effect sizes here. Why are you getting desk rejected on this data in journals? What's the issue?
Sometimes I don't get any feedback at all, and other times the feedback I get is something like one time I got the feedback section just said inappropriate. That was all it said. Another feedback response was, this has been done before. Although I would argue that salivary hormones in these exact Division III athletes haven't been done before, and the manner in which we did it hasn't been done before. But yeah, those are the types of things. And so,
I think I saw maybe your point to the small sample sizes, and one thought was maybe, since they're both a general linear model, ANOVA and OLS regressions, maybe pool your samples together, across sports, and then run some regressions, like a fixed effects or something. Then it's the same results as you'd see because it's a general linear model, but it might be a little more sexier. And with a pooled sample, then you'd be able to, have a larger sample size, and someone might see that. And the same things, but they might say, oh, this is kind of interesting, because I could see how us doing ANOVAs with a small sample might freak people out,
Cool. Thank you.
Just a thought.
Thanks, I appreciate that. I'll look into that. All right. Well, thank you all very much.